All right, welcome everybody. This is 2.2, classifying and simplifying polynomials. All right, so we're going to be focusing a lot on polynomials. Polynomial meaning many terms, so it's going to have different parts. This example would be a polynomial. It has three parts. This is one part. Oops, I don't know why this isn't working. One part, two parts, three parts. Those are called terms. So this example has three terms. Okay, and let's do a little vocab really quick on these for a polynomial. So polynomials, first off, let's talk about coefficients. We've already talked about coefficients when we did 2.1. Coefficients are the numbers that are in front of variables. So for this example, we have, for the first term, our coefficient is 2. For our second term, our coefficient is a -1. And then the last term doesn't have a coefficient, okay? Our next vocab is constant. So constant is a number on its own. It doesn't have a variable with it. So if you plugged in for any value for x, if you plugged x in for 5 or 10, this last term is constant. It never changes, okay? All right, next off we have is the number of terms. So we kind of talked a little bit about terms. So these are terms. Terms are combinations of numbers and variables. Okay, terms are usually separated by pluses or minuses. Okay, maybe we could change that to be a plus to give an example for that. But so this has three terms. So for this one, it's just asking, what is the number of terms? So for this one, our answer would be 3. It has 3 terms. Okay, why is that important? Well, we're going to be able to classify a polynomial based off of the number of terms, just like we can with degree. So degree is the highest exponent. So if we look at this example, what's the highest exponent? Well, the constant doesn't have an exponent. This term has an exponent of 3, and the leading term has the highest exponent of 4. Okay, so for this example, the degree of this polynomial would be a degree of 4. Okay, so we're going to do a couple examples, more examples of that, and hopefully that will be more clear. All right, again, you can also classify it by degree, and we'll get into that next. So we can classify by terms. These are the ways we can classify by terms. So if the polynomial only has one term, so for example, we could have, this is an example, we could do 2x to the 5. Okay, that would be called a monomial. Mono meaning one. If it has two terms, so for example, we could have 2x to the 5 plus 1. That would have two terms, and we could call it a binomial. If it has three terms, you could probably come up with your own example here, but I'll shoot one out there. So 2x to the 5 plus 3x minus 1. Okay, that would be a trinomial. And if it's 4 or more, we're just going to call it a polynomial with that number of terms, so 5 terms or 6 terms. Okay, so just kind of think of those prefixes: the mono, bi, tri. Mono meaning like monopoly, one. Bi meaning like bicycle. Tri meaning like tricycle, 3 wheels, right? Okay. We can also classify by the highest exponent. We call that, again, the degree. So if the degree is 1, we call it linear. You're probably familiar with linear equations. So an example here could be something like 2x plus 1. Okay? You don't see the exponent, but the exponent would be a 1 on top of that x. So that's a linear equation. It's also a binomial because it has 2 terms, okay, for that example. If it has a degree of 2, then we call it a quadratic. And we're going to use that a lot this year. We're going to learn a lot about quadratics. And then when you get to secondary math 3, you're going to do higher polynomials, okay, like a cubic, which is our next one we're going to talk about. So here's an example of a quadratic. Could be something like, I don't know, 3x squared, okay, or 3x squared plus 1, or 3x squared plus 1x minus 5. So those are all quadratics. This last example, this would also be a trinomial because it has 3 terms. So a quadratic trinomial. All right, and then our third is, I said, is the cubic. Kind of like it's a 3-dimensional thing, right? So like a cube has 3 sides, or not 3 sides, but 3 dimensionals, right? So an example of this would be something like 2x to the third plus 1 would be a cubic, and with 2 terms it would be a cubic binomial, okay? So we'll just cubic. Anything above that, we're just going to call it like a 4th degree polynomial or a 5th degree polynomial. All right, so let's just do a couple quick examples. We're just going to identify this information. So for example A, list the coefficients. Our coefficient would be -10. The constant would be a -1. Number of terms would be 2. If it has 2 terms, we call it binomial. And then with degree, again, we don't see it here, but there would be an exponent of 1 on that b. And again, if it has a degree of 1, we call it a linear. It only takes one, it's like one-dimensional. A line is one-dimensional, okay? All right, here's another example. Coefficients, we've got -2 and -2. Constant of 7. Number of terms, we have 3 terms. If it has 3 terms, we call it a trinomial. Oops. Trinomial. And the degree here is a 2. So, and that's called a quadratic. All right, last 2 we're just going to classify. So, degree, or classify by terms. The terms, we have 3 terms. 3 terms, which is trinomial. And degree is a 3, so this would be a cubic. And then our last one is a monomial. It has 1 term. And its degree is 2, so we would call that a quadratic. Hopefully that kind of makes sense. If you have questions, just let me know. All right, and then the rest we're going to do operations with polynomials. So today we're just going to focus on adding and subtracting. A part of that is called combining. We'll need to combine like terms. So that's the first thing we'll talk about is combining like terms. If you want to combine like terms, just remember that they have to have the same variable and exponent. So let's look at this first example. See if you can pause and see which of these terms are like terms. Okay, so I would highly recommend that when you do these, that you will always look for your highest exponent and then work your way down until you find the constant. It will help you in the long run. I'm going to ask you to write your answers in what's called standard form. And standard form means that you have to have your exponents ordered highest to lowest. So for this example, we'd look for the highest. We have our x to the 2's, our x squareds. Okay, those are like terms. We can't combine these two. They don't have the same exponent. Okay, so we'll just add those together, combine them. 5 subtract 3 would give us 2 x squareds. Just think of it kind of like x squareds is like bananas, right? We're taking 5 bananas and we're going to subtract 3 bananas. The bananas aren't changing, okay? The exponents, when you combine like terms, they always stay the same. So it's not going to give us 2x to the 4th. We don't add exponents like that. The exponents only change if we're multiplying or dividing the bases. So if you kind of refer to our last lesson, that might be helpful. All right, our next highest would be our x's. Those would be x to the 1s. We don't have to write those, obviously. Okay, so what is 2 subtract 6? So that would give us negative 4x. All right, and then all we have left is our constant. Actually, I'm going to do that. Our constant here is plus 13. So if you have something that doesn't have any like terms, then we're just going to write them down. Okay, I'm going to shoot through maybe this last example. All right, so again, always start with your highest. Here is our highest, our x to the 4th. Our next highest would be our x to the 3rd. Has no other like terms, so we'll just write it down. Next would be our x's, and that's all the rest. They all have x's. What about this last term? It doesn't seem to have a coefficient in front of that x. So again, if that's the case, you can always put a 1 there. Okay, so we've got 12 plus 5 plus 1 would give us 18. As you notice, these go from highest to lowest exponent, so that means that we're good to go. It's in standard form. All right, finish off the last two. We would start with the m squared, then we'd have our minus 7m, and then we would combine these constants. So 6 plus 8 to give us 14. And then for D, same sort of thing. You've got our n squareds. So 2 subtract 8 would give us negative 6n squared. And then we would combine the n terms. So 2 plus 7 gives us 9n. All right, so now let's do some, Our next thing, before we get into adding and subtracting, another thing that we can do to simplify polynomials is we can distribute, use the distributive property. Just remember that when we distribute, we're just multiplying everything that's in front by everything that's inside. Okay? So we've got 5 times negative 4x. Again, these are the 5 and the negative 4 are coefficients, so it means we can just multiply them like normal. We get negative 20, and then we'd have our x. And then we'd times that 5 by the 1, and make sure it's in standard form. So this one's in standard form. Check. All right, next we can do our next example. Again, we're going to distribute not just the x, but the negative 2x. If it's helpful, we can always put a 1 in front of that x squared. So we're going to multiply the coefficients. That's negative 2 times 1 is negative 2. And then x times x squared. Again, if we're multiplying like variables, we can add their exponents. So that's like x to the 1 times x to the 2 would give us x to the 3. All right, and we'd do it 2 more times with the other terms. So we'd get negative 6x squared, and then we'd get positive 4x. Okay, so just remember a negative times a negative would give us a positive. All right, last two. So as you notice here, what's in the parenthesis is not in standard form. So you can rearrange that now if you want, or you could just save it till the end. I'm just going to save it to the end. So here we get 6x, and then we get minus 2x squared. And then we just need to rearrange those. Again, the negative goes with the 2. So we'll have negative 2x squared, and then plus 6x. Last example, we want to distribute. we get 2x to the third times negative 1x squared. Okay. All right, now let's get into our adding and subtracting, and then we'll be good. Okay, so adding and subtracting. The parentheses here are just showing us what are the two polynomials. So this has two polynomials. One of the polynomials is a binomial, two terms. I guess they both do, and they're both linear equations. Okay. If you are adding, just remember that you do not, like basically the parentheses, they're just kind of grouping for grouping's sake. It's not going to change your answers when you're adding. You're just going to combine like terms. So we've got 2x plus 4x gives us 6n. I don't know why I was saying x's. Okay. And then we could do negative 7 plus 3. So that would give us negative 4. All right, here's another example. Let's do another adding. Here's another adding. So this is example D. Again, we want to maybe start by finding like terms. So here is a negative 8x to the fourth and a positive 7x to the fourth. So again, we're adding those together. So we would get negative 1x to the fourth. Then go to the next highest. There's no other x to the third, so we'll just have negative 3x to the third. And then we have, so I'm going to make this a little so fat. There we go. There's no x squareds. There's no terms with x's. So we just add the coefficient, or sorry, the constants. So 6 plus 5 gives us 11. Okay, now let's talk about subtraction. Okay, so if we are subtracting polynomials, you got to be aware that we're subtracting everything that's in the second parenthesis. So that is the distributive property. We're going to take that negative or that negative 1, and we'll need to distribute to both of the terms inside. So that would be like negative at 6, and then we'd have plus 8m squared. And then we'd still have the left side. Doesn't change, right? Okay? And then we'll just combine like terms. So we've got our m squareds. We've got negative 3 plus 8. And that would give us 5m squared. And then we could do our constants. So 5 subtract 6 gives us negative 1. All right, last example. So again, if you are subtracting, we need to make sure we distribute the negative. Some people kind of just do it in their head, and I'm not opposed to that. Just be careful, okay? So here we get negative p and then plus p squared. And then we'll combine like terms. So we've got p squared and a p squared, or 8p squared plus p squared will give us 9p squared. And then we'd combine our p's. So negative 7 subtract 1. So that would give us negative 8p. All right, well, if you have any questions, please let me know. I'm happy to help you. We'll see you later.